Welcome to Metrology lecture series. In the present video, we will discuss the angular measurement by the autocollimator. An autocollimator is an optical instrument used to measure very small angles or very small angular changes with high accuracy. Autocollimator is mainly used for checking small angular differences, detecting tilt or deflection, inspecting the flat surfaces, precision alignment of the machine parts, and verifying the angle standards. Let's see the principle of working of the autocollimator. When the light source is placed at the focus of collimating lens, the light comes out as parallel rays. So in the figure you have to observe that one, here light source is placed at the focus of the collimating lens. Then when this light is passes through the collimating lens, it comes out as the parallel rays. If these parallel rays strikes a plane mirror which is placed exactly perpendicular to the axis, then light is reflected back along the same path and focuses at the same point. So here observe that when the plane mirror is placed exactly perpendicular to the axis of this light, then light is reflected back along the same path and it has to be focuses at the same point. So now let's see what happens when the mirror is tilted. If the mirror is tilted by a small angle theta, then reflected light beam deviated by 2 theta. So in the schematic you have to see this one. So mirror is tilted the angle theta, then this reflected beam is deviated by 2 theta. This reflected beam is now forms an image slightly shifted from the original position. See here. So initially this is the positions at this position. So when the mirror is in the exactly perpendicular to the light axis. Now mirror is tilted in the 2 theta, then image is forms in this position. So it is the shifted from the original position. That shift let consider the x. So now this is the x. So this shift x or maybe this displacement x is given by x equal to the 2 theta into f. So here f is the focal length of this collimating length. So this is the focal length f. Now this displacement x equal to the 2 theta into the f. Let's see the construction of the autocollimator. First part is the light source or maybe the lamp. So light source or lamp provides the illumination to the system and it is usually placed near the graticule. So let's see the graticule. Graticule or crosshair target. A pattern is used as a reference is called as the graticule. Its image is projected and later is observed. So next one is the beam splitter. So this is the beam splitter. It is a semi-transparent mirror which is placed at 45 degrees. So this beam splitter has the two functions. One is the reflect the towards this objective lens, and moreover it will be allows this reflected light from the objective lens towards the microscope. So this beam splitter has the two functions. One is the reflect towards the objective lens, and moreover it has to be allows the reflected light from the objective lens towards to the microscope. So this is the function of the beam splitter. And next one is the objective or collimating lens. So this collimating lens convert the light into the parallel rays, and moreover it also focuses the returning light to form the image, and moreover it is having the one more function. So first function is it is convert the parallel rays, and moreover so this parallel rays is hit the mirror, then once again it has to be so pass over the objective lens, and it is the focus and returning light from and also form the one image. It is the so focus the at particular point. So it is also having the two functions. And next element is the reflector or maybe the plane mirror. So this reflector or plane mirror is placed in front of the instrument. So it reflects the light back into the system, and moreover its tilt is what we have to measure. And next instrument is the micrometer microscope or the eyepiece. Generally these eyepiece or the micrometer microscope is used to observe and measure the image shift. So have to see here. So with the help of the eyepiece or maybe the microscope, we can be observe the measure the light shift. So it contains a scale for the precise readings. So this is the construction of this autocollimator. So next we have to discuss about the micro-optic autocollimator. The principle of this micro-optic autocollimator is the micro-optic autocollimator works on the optical principle. Let's see the working. So in this one, a pair of target wires is placed at the focal plane of the collimating lens. So this is the focal plane of the collimating lens. So here we have to place a pair of the target wires. So that is we are also calling as the crosshairs. So this target wires are placed at the focal plane of the collimating lens. These wires are illuminated by a lamp and condenser, and their image is projected the forward. This projected image strikes a plane mirror, so that is we are calling as the reflector. Then the reflected light comes back and forms a image. So observation. So through the microscope eyepiece, we can see the original target, and moreover we can be observe the reflected image of the wires. Next we will discuss the measurement of the micro-optic autocollimator. The microscope contains the adjustable setting wires. So here you have to observe in the schematically. Here there is the setting wires are there. So which has to be, these are the adjustable setting wires. And these wires are moved using the micrometer until they coincide with the reflected image. So next we have to look for the accuracy of the micro-optic autocollimator. So eyepiece scale is graduated in 0.5 minute, and also micrometer moves the wires by 0.5 minute per revolution. So this divided into the 60 parts. So next we have to look for this micro-optic autocollimator have to having the two direction measurement. These two wires are placed at right angles, so which has to be helps the measure the tilt in both horizontal as well as the vertical directions. So this is regarding the micro-optic autocollimator. So next we have to discuss about the applications. Micro-optic autocollimator having the applications. So this is very important. So it is used for the machine tool alignment and the testing. And also this is suitable for the measuring very small angular deviations and used in precision engineering and large scale measurements. So next we have to look for the applications of the autocollimator. So these are the very important for the competitive exam point of view. So first one is the measurement of straightness and flatness. So straightness and flatness we can be measured with the help of the autocollimator. So this is used to check whether a surface is perfectly flat or straight, and moreover it is very helpful in quality inspection of the machine parts. So next application is precise angular measurement. So this autocollimator is used with optical polygons for the accurate angle setting, and it is the common in the calibration labs. And next application is comparative measurement. So this autocollimator is used to compare unknown angles with the standard angles, which has to ensure the high accuracy. Next application is checking squareness and the parallelism. So which has to be helps in and verify the whether two surfaces are perpendicular or whether the two surfaces are the parallel. Next application is measurement of small linear displacement. Small angular changes can be converted into linear displacement, which is useful in the precision engineering. And last applications very important. So machine tool alignment and the setting. So autocollimator is used for the aligning the machine tools and checking the spindle arrangement and setting up for the precision equipment. So this is regarding the autocollimator, and thank you.